Hey guys, how are you all doing? Welcome back to my YouTube channel, Study Don't Worry. In this video, we are going to study the chapter Atomic Structure from Chemistry. There was a part 1 video on this before made, so to understand this chapter, kindly go and view the atomic structure part 1. So without any delay, let's start. So, atomic number and mass number. Let's see what is atomic number and mass number. The number of protons present in an element is called the atomic number and it is denoted by Z. And then atomic number is the equal to number of protons and number of electrons. So number of electrons and number of protons is nothing but the atomic number. And the sum of protons and neutrons is called as mass number. It is denoted by A. So you can find out the number of neutrons by mass number minus atomic number. So this equation we should remember as they might ask in the exam to find the number of neutrons with mass number and atomic number given. Now let's see the symbolic representation and relative atomic mass. So element is represented in the following way given in the diagram. I'm showing it to you with the laser pointer. So let us think X to be the element. Here we have A, that is the atomic mass. It is on the top, and Z, that is the atomic number. It is at the bottom, and X is the element which is at the middle. So this is how an element is basically represented. The relative atomic mass of an element is the number by which the average atomic mass of an atom of an element is heavier than 1/12th part of the mass of the carbon atom, that is 12. So it is nothing but the ratio of the average atomic mass by ratio of the carbon atom, that is 12. And you should always take it as the mass. Atomic number won't work out here. Next, isotopes. Atoms of the same element having same atomic number but different atomic mass are called atomic isotopes. So some elements may have same atomic number but they have different atomic masses. This may be possible in the case of hydrogen. It has 3 isotopes: protium, deuterium and tritium. So it's a very good example of isotopes. Electronic configuration. Electronic configuration is a very important topic, so it makes us very important to understand this. This also helps in finding out the valency of an element. So we need to clearly understand the electronic configuration. So the arrangement of electrons in different orbitals around the nucleus of an atom is called electronic configuration. And this was proposed by Bohr and Bury. Bohr and Bury were two famous scientists who gave the arrangement of electrons in different orbitals. The shells are named as K, L, M, N and so on. The energy level increases as they move up in order. The first shell K can accommodate only 2 electrons, but all the other shells can accommodate 8 electrons. So the first shell, that is K shell, can accommodate 2 electrons, but other all shells can accommodate 8 electrons. Now I'll show you how does the electronic configuration works. So first let's take the magnesium, and to do the electronic configuration, we need to know the atomic number. Atomic number is very important. So here the atomic number of magnesium is 12, as we all know. So this is magnesium. And first comes the K shell. I'm showing my laser point. So this is the K shell. It has 2 electrons. As I said, it can accommodate 2 electrons. So there are 2 electrons here. So 12 minus 2, 10. Now the next shell can accommodate 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So 8 are done. 8 plus 2, 10. 12 minus 10, 2. So still 2 electrons are left. The 2 electrons are given in the valence shell, that is the valence electrons. So there are 2 electrons. So this is how electronic configuration is diagrammatically represented. So magnesium, the first layer has 2 electrons, then 8 electrons in the next layer, that is the L shell, and M shell has 2 electrons. 2 plus 8, 10. 10 plus 2, 12. So there are total number is 12. Let's take another example of oxygen. It's a very simple one. So first K shell, which can accommodate only 2, then 6, 1, 2, 3, 4, 5 and 6. So the total is 8. So when 2 is there, remaining is 6. So the valence electrons are 6. So this was it, easy and simple, and this is electronic configuration is very, very important. Next comes the valencies, and the valencies found out by electronic configuration. The outermost shell is called the valence shell, and the electrons present are called the valence electrons. Okay, so the outermost shell, it can be any shell, it is called as the valence shell, and the electrons present in the valence shell are called as the valence electrons. And valency is the number of electrons needed to be shared, donated or accepted to form an octet. So to understand this, first you need to understand an octet. So octet is nothing but there should be 8 electrons in the valence shell. That is, the outermost shell should form an octet, either 8 electrons or 0 electrons. It should not be in a state where it has 2, 3, 4, 5, 6. It should not be in any state. It should either be 8 or it should either be 0. So to make it 8 or 0, it will be either sharing it, donating it, or accepting it. So let's see how valency is working here. So let's take some example. Let's take an example of sodium. So here sodium atomic number is 11. So we'll do the electronic configuration. K shell 2. Then we have the L shell 1, 2, 3, 4, 5, 6, 7. And then we have 2 more electrons. Then we have 1 electron at the last, which is nothing but the valence electrons. So we see that this is not stable. This element is not stable. Why is it not stable? Because the valence shell has the valence shell, that is the valence electrons, is 1. And as I said you, the elements should have either 8 or 0. So now what does it do? It has 1. So what does it do? It donates off 1. It donates 1 and it becomes 0. So it should either be 0 or it should be 8. So it donates 1 and it becomes 0, and become the valency is nothing but 1. Because it donated 1 electron, the valency becomes 1. So this is how it works. So when there are totally 8. So in 8 electrons, if it is less than 4, then it will donate. If it is more than 4, then it will accept. So this is how valency works, and valency as electronic configuration is the most important topic of this chapter. So this was it, guys. This chapter, it was very simple. It was very easy, and hope this helps you a lot during your exams. Thank you. Goodbye.